بسم الله الرحمن الرحيم. نحاول خلال هاي المحاضرة أن نحل هذه السؤالين. السؤال الأول determine the required work for compressor of two stage. Air enters the first stage cylinder by a rate of 3 meter cubic per minute, pressure 100 kilopascal and temperature 27 degrees centigrade, and the compressed to the final pressure of 3500 kilopascal. The air is cooled in the intercooler to 5 degrees centigrade and 700 kilopascal. The compression is adiabatic at the two stages. The solution: two-stage air compressor with adiabatic compression, BV to 1.4 equal constant. V1 dot equal 3 meter cubic per minute. V1 100 kilopascal. T1 to 7 degrees centigrade equal 300 Kelvin. V2 700 kilopascal. T2 dash the intermediate temperature 50 degrees centigrade 323 Kelvin, and V3 equal 3500 kilopascal. Analysis: the mass flow rate is m dot v1 dot v1 by r t1 equal 3 into 100 by 300 into 0.27 equal 1.287 kilogram per minute. The work done in the first stage is W1 equal K by K minus 1 m dot R T1 B2 by B1 to power n minus 1 by n minus 1, and by substituting L known values we can get that W dot 1 equals 780 kilojoule per minute or 13 kilowatt. The work done in the second stage, W dot 2 equal K by K minus 1 into M dot R T2 dash into B3 by B2 n minus 1 by n minus 1, and by substituting the known information we can get W dot 2 equals 640 kilojoule per minute or equal 10.66 kilowatt. W dot total equal W dot 1 plus W dot 2 and equal 13 by plus 10.66 and equal 23.66 kilowatt. Example 6. Air enters two-stage reciprocating compressor at a rate of 2 kg per minute at a pressure of 600 kilopascal and temperature 300 Kelvin. The pressure at the end of the second stage is 3000 kilopascal. The pressure between two stages is 500 kilopascal, and the intercooler is ideal. Cooling water enters the intercooler at 10 degrees centigrade and leaves at 20 degrees centigrade. Determine the mass flow rate of cooling water in the intercooler, the power required to operate the compressor if the compression is according to B into V to power 1.31 equal 0. This is a compressor of two stages. The flow rate is 2 kg per minute. B1 equal 100 kilopascal and T1 equal 300 Kelvin. The pressure at the end of the two stages of the second stage is 3000 kilopascal, and the intermediate pressure is 500 kilopascal. The water enters the intercooler at 10 degrees centigrade and leaves at 20 degrees centigrade. It is to determine the mass flow rate of water in the intercooler and also the work done by required to operate the compressor. This is the compressor. This is the first stage. it become bigger because the air has high volume, and then the second stage is the smallest because its volume of air it's become small. The water enter the intercooler at 10 and leaves at 20 degrees centigrade. It is to determine the mass flow rate of water m dot w and also the work done. The analysis to find the temperature at the end of first stage, T2 equal T1 into B2 by B1 into N minus 1 by N, and this give that T2 equal 439 Kelvin or 1660 degrees centigrade. And from the heat balance equation, M dot W CBW TW2 minus TW1 equal M dot A CBA T1 minus T2, and M dot W equal 4.18 into 20 minus 10 equal 2 into 1.005 1660 minus 27. From this we can get that M dot W equal 2.1005 minus 1660 minus 27 by 4.18 into 20 by minus 10. It will give at the temperature of 3.342 kilogram per minute. The power required or the power consumption in the first stage compression is W dot 1 equal N by N minus 1 MRT1 into BT by B1 to power N minus 1 by N minus 1. It will give that W1 equal 337.3 kilojoule per minute or 5.6 kilowatt dividing by 60. The power consumption in the second stage W2 equal N by N minus 1 into MR T2 prime into B3 by B2 into N minus 1 by N minus 1, and it will become 384.27 kilojoule per minute or 6.4 kilowatt. The total power consumption in the compressor is equal. الطاقة المستهلكة الكلية في الكمبرسor هتساوي لنا W dot total W dot 1 plus W dot 2 equal 5.6 plus 6.4 and equal 12 kilowatt. Thank you for your listening.